Hi everyone, welcome back again. So in this video, we're starting our maths series. So I've realized that I've been solving a lot of maths problems, and sometimes I do acknowledge that some students may be struggling with maths, whether it's algebra. Well, we haven't done much of calculus, but I'll also touch on calculus as well. So I'll start making videos both in maths and physics. So I wanted to start today with simultaneous equations because we use this a lot in physics, and you just basically need to know how to solve simultaneous equations. So before I start, make sure that you check out our other videos, and you also read the description to see where you can find us, and also where you can actually send your questions. I'll have everything on in the description, and then make sure that you subscribe, and also you like the video. If you like the video, leave comments as well. If you want to leave comments, that would be very much appreciated. All right, so simultaneous equations, generally how we use them is whenever you have two variables. All right, so x and y, they are called variables. So if you have two variables which are unknowns and you have one equation, you won't be able to solve it. So let me say, for instance, I did not have this equation. If I don't have this equation, basically you can't solve. I mean, you could say, for instance, maybe you could say 3x is going to be equals to 4 and then minus y, but that's it. You still don't know what is x, you still don't know what is y, so you can't do anything. So you need another equation that will actually assist you to actually solve this. So I think I had yx here minus 2y is equals to 5. I think that's what I had at the beginning. All right. So now you need another equation. Then now you have two unknowns and then you have two equations. So that's basically when and how you know whether you're going to need another equations from somewhere or not. Now the question is, how do you solve these ones when they are like this? All right, so you could do substitution. So that's the first one. You could just solve it by substitution. Some people prefer that way, and then students do it like that. You could solve it by substitution. So let me show you both methods. So you could actually say, where you see x, so this basically becomes equation 1. You call this equation 1. This becomes equation 2. So one way we can actually solve this equation is by substitution. So what you do with substitution is you pick one that is easiest to solve. For instance, you decide whether you want to solve for y first or for x first. If you look at the equation, y is easier to solve here because if you just take this and put it this side, you are left with y. If you look at this equation, x is easy to solve because you can take this term, transpose it to this other side, and then it becomes positive, and then you're left with x. What I will do is I'll just rearrange equation number 2. So when I rearrange equation number 2, I'll end up with x is equals to 5 plus 2y. Then I'm going to name this equation number 3. Then I will take this equation number 3 and then I am going to substitute it into equation number 1. All right. So meaning that when I look at equation number 1, wherever I see x, I am going to actually put all of this. That's basically what you mean. You're going to substitute x with what you see on the right here. So equation number 1 looks like this. It has 3x plus y is equals to 4. So when I substitute, I'm going to have 3, which is this 3. Where I see x, I'm going to put this. So I'm going to open a bracket and then 2y. And then this is plus y, which is equals to 4. All right. So I can actually now multiply this 3 multiplied by 5, this 3 multiplied by 2y. So I end up with 3 multiplied by 5 is going to be 15. And then there's a plus sign between them. And then this 3 multiplied by 2y. Basically it's 3 times 2, which is 6, and then this is y, and then plus y, and then this is going to be equals to 4. So you can see that I have 15 plus 7y is equals to 4. I take this 15 to the other side, it becomes negative, it becomes 7y is equals to 4 minus 15. and then basically 7y is minus 11. And then what you then do is you just divide by 7 both sides. You divide 7 on the left hand side, 7 on the right hand side. It gets rid of this 7. You are left with 11 divided by 7. All right, so basically this is how you find y. You can call this y equation 4 if you want. It's not a problem. Now you can take this y, you can either substitute it on equation number 1 if you want, or you substitute on equation number 2. It doesn't matter. You should get the same answer. I'm going to substitute it in equation number, I think the easiest is going to be equation number 1. I think is going to be easy. So equation number 1 looks like this. It is 3x plus y is equals to 4. Okay, so now where I see y, so I'm doing substitution again. So basically I am going to put equation number 4 into equation number 1. Okay, so where I see y, I'm going to say 3x. Where I see y, I'm going to put minus 11, so it becomes plus. Where I see y, I put minus 11 over 7. Okay, and then basically this becomes 4. All right, now from this one, now there's two ways you can approach it if it's a fraction like this. I can show you both ways, depending if you, all right, okay, this basically becomes 3x minus 11 over 7 equals to 4. So you could just say 3x, this is 4, plus 11 over 7. So you could do it like this. And then basically this becomes, this means that 3x is going to be equals to 7. And then you say 7 multiplied by 4, which is 28, plus 11. And then basically you have 39 over 7. Okay, so you basically have a situation whereby you have 3x is equals to 39 over 7. So you divide by 3, and then basically this becomes like this, 1 over 3, 39 multiplied by 39 divided by 7. So basically x becomes 39 over 21. So 3 can go into both 21 and 39, so you can simplify this further, and then this becomes 13, because 3 goes 13 times into 39, and then it goes 7 times here. So basically this is x. Now you can check if this is actually correct. You can check if this is correct. So let's just check. I already know what is y, I already know what is x, so let's just check. Let me use a different pen. So remember, equation 1 is 3x plus y is equals to 4. So let me substitute x and y and see if I'm going to get 4. Right? If I get 4, it means that the values that I have for x and y, they are correct. So let's just see if 3x plus y is going to be equals to 4. So let me take this one out. So I'm going to have 3, where I see x, I'm going to put 13, sorry, over 7 minus 11 over 7. Okay. And then this is actually going to be equals to, this is 33. Is it 33? 3 times 10, yeah, it's going to be 39 actually. 39 over 7 minus 11 over 7. So everything is basically 11 here. Okay, so 39 minus 11. So basically we have like 7, 39 minus 11. And this is 28 divided by 7, which is 4. So it is correct. So both my values are correct. You can also check with the other equation as well. The other equation is x minus 2y. Now this one is supposed to be 5, so let's check if this is going to be 5. X is 13 over 7, and then this is 2 times, and then this is minus 11 over 7, and then basically this is 13 over 7 minus 22 over 7. Okay, and then this one is going to be plus. This one in this case is going to be plus. So this is going to be 30. Basically, this is 7. 13 plus 22. And this is 30, 35, 35 over 7, which is equals to 5. So indeed, so both my x and y values are actually correct. All right, so this is fine by substitution. I'm going to make another video, and then in another video, I'm going to solve the same problem, but now I'm going to use a different method. Basically, I'm going to be eliminating. Basically, that's how I'm going to be using it. All right, solving them simultaneously. Okay, all right. Otherwise, guys, I'll see you in another video.